Thank you, Anastasiia.
So, hello. Hello. I think this is the last talk for today, right? Feeling tired? No? Okay, you might be a little bit tired after this talk. Just, a little bit. I will complain. I will complain a lot. And this is not a deep cryptography talk. It's mostly about software engineering, about library design, about specifics of different languages and different operating systems. So, actually, when I submitted a call for papers for this talk, the name was Maintain Cryptographic Libraries for 11 languages, but now we have 12. So for the last half a year, we have added another one, and I'll show that 12. Actually, the last one is not like a language, it's a platform. We added WebAssembly. And right now we can cover, even all those Electron applications. Okay, so my name is Anastasiia, and I am software developer. So I came from software developer world. I was doing a lot of applications, and then I switched to security. And for many years right now, I'm working in a data security company, working with cryptography, but not on a ciphers level, more on a protocols level, data protection level. So protecting data for different kinds of applications. And the company I work called Cossack Labs. That's UK company, but of course you can see some Ukrainian root there. Yeah, I'm from Ukraine. So that's UK company, and we are vendors of security software, mainly based on cryptography, mainly for data protection. Usually our software, like other companies, integrate our software to protect data, to encrypt data all the time. And the thing is that we have a really nice cryptography team, and we are working on, novel technologies, not on ciphers, but mostly on the protocols, trying to solve typical business use cases with cryptography. So anyone will have any access to data. For example, like searchable encryption, like zero knowledge authentication, like authentication using zero knowledge proof protocols, like data collaboration on end-to-end encrypted data, these kind of things. And we put these research into libraries, and we usually open source it. And then based on some of these libraries, we create our software, and then we sell it. So it's like multi-layered thing. And today I'm gonna tell you about one of these libraries we open source and we support, and many other people use because it's free, it's open source, yet another cryptographic library, and how actually, complicated it is to support multi-platform library. So let's start. Yeah, obviously in crypto we trust, and by crypto I don't mean blockchain. No. Today for this talk, crypto is cryptography, okay? Okay. Yeah, so in crypto we trust, but not only in any crypto, in usable crypto. Because all these mistakes developers do trying to use cryptographic instruments. And we kind of try to eliminate them. Today we're going to talk about Warren Crypto, about the Themis as a library, about what's the difference between easy to use and hard to misuse. Okay? And about security testing and all these things developers should do, like maintainers should do to prevent developers making mistakes. And they always try to make mistakes. Okay, so let's start. Let's start thinking that we are software developers. We don't know a lot about security. We don't know a lot about cryptography, because most software developers are like this. And we have a very, very simple use case. We need to protect the data. For simplicity, we need to protect stored data. So it's data at rest encryption, really easy, should be. However, as a developers, there are really many things we need to think of trying to protect this data. First of all, which kind of data to protect, right? Many people, many people, they make the same mistake with data scope. Because we have some data sensitive for our business, and we believe that this is only user PI, only names, emails, yada, yada. But No, usually for some businesses, likes and preferences that we as a company collect about our users is also sensitive data, that we will lose money if we will lose this kind of data. So we need to protect it as well. Then there is different kind of regulations depending on the industry. GDPR, PCI DSS, HIPAA, DPB, lots of them. They also push us as a company to protect different kind of data. Right? And last but not least, the technical data. All these accesses, API tokens, email and passwords, AWS tokens that we store in our infrastructure somewhere, and we also might need to protect some of these bits. So first mistakes developers usually do, they underestimate the scope of protected data. But let's say that we did a great job, we did a risk management, and we know which data to protect. Like, okay, now next step is let's select a cipher. And you know how many ciphers there are, like for simple symmetric encryption? Can you name some of them? Ciphers for data encryption at rest. IS, right? Blowfish, good choice. 2019. Tofish, Ghost, Kuznechik. Oh yes. Okay, so IS. Okay, let's say that's IS. However, which IS mode? Which padding to use? What IV, what init vector we need to use? Which key length to select? Then, when we say key, obviously we mean a cryptographic key, and it's different from password. So how to derive this key? What derivation function to use? Then, of course, when we start having keys, we start having key management problems. We need to exchange these keys. We need to store these keys. We need to revoke accesses. Probably we will have some key management systems. KMS, HSM, yada yada, depends on our infrastructure, our system. Last but not least, our small let's protect the data exercise in a huge infrastructure causes us to support all these things on multiple platforms and probably to backup our keys. And the question is, if we backup keys, how we will protect our backups? Shall we encrypt them? Where to store encryption keys for encrypted backups? In another backups? You know the thing, yeah, you know. You will end up having a master key as a QR code on paper in your safe. I'm not joking, really. This is a kind of good way to do. Well, not a perfect one, but one of. Poor developers. I've been there. Just to protect the data, storage encryption, sure. I read this research like 3 years ago, probably. So the thing is that people analyzed different vulnerabilities in different applications, and they tried to divide it into two large groups. The group number one, vulnerabilities in applications caused inside crypto libraries. And the second group, vulnerabilities inside applications caused by misusing crypto libraries. And now, guessing game, guess the numbers. So 100%. Let's guess the number. How much vulnerabilities were caused by misusing crypto libraries? 99. Good one. Try more. Like close enough, but not so bad. Again? 75. Okay, 99, 75. 98. Close enough. 83. But you get the point. Of course, after this kind of introduction, it was easy to estimate, right? Most bugs in applications with cryptography are not inside cryptographic libraries, but in misusing cryptographic libraries. Because, there are really a lot of ciphers in the world and many cryptographers. Yes, Jean-Philippe, many cryptographers are super excited about making new ciphers. But developers, they don't need new ciphers. They don't need blockchain. No. What developers usually need is boring crypto. Concept by Daniel Bernstein. Boring crypto, of course, that's an idea. That's imaginary cryptography that always works. That you can't misuse. You don't need to update. It just works. It stays there. It works. It's strong. It's usable. And, it's a perfect world. Again, utopia, yeah, utopia in cryptography. So boring, okay, it's important. Boring in cryptography means good. Okay? So, boring crypto, of course, this is just a concept. But there are many libraries and many developers, they try to achieve, try to get to this concept as close as possible. Because boring crypto says that instead of giving ciphers, we should concentrate on use cases, as developers may have, how to store data securely, how to verify the source of data, how to send data protected to each other, right? Of course, we understand that inside these use cases, we still have ciphers, key management, all the things, but they are kind of covered by high-level API. And now, with all this nice introduction, let's deep into nightmare of developing and supporting this kind of high-level boring crypto API. So today we're going to talk about Themis. Themis is this cryptographic library I maintain and our company is maintaining, free to use, open source on GitHub, used a lot among multi-platform applications. And when we were making Themis 5 years ago, we were inspired by this concept, by Bernstein. Of course, I read about boring crypto only 2 years ago, and I thought, oh, this is what we were talking about. So even, without knowing the concept before, we kind of understand that, yeah, this is our goal. And the thing is that in Themis, we use the same idea, we use the same train of thought. We decided that, okay, let's think about use cases, how developers might need to use the cryptographic libraries. And we come up with 4 large use cases that we call crypto systems. Very simple, very simple. I want to store data encrypted. I want to send data to someone, right, directly encrypted. I want to encrypt some long communication, some long session. And I want to authenticate. For each of these use cases, we created a crypto system that uses ciphers, but it uses a combination of ciphers. And for developers, the API is very high level. So for storage, we call the thing as secure cell. You kind of put data in a cell. In Lipsodium, the similar idea is a secure box. You put data in a box. To send someone data, to send someone particular data, we call it secure message. Again, in secure cell, we use an IIS 2 mode, and we have this built-in key derivation function. So developers, can submit, can use not really long, can use not cryptographically strong keys. We still have a KDF inside. For secure message, we have this built-in key generation, key management. So developers can you call hey, I want to encrypt this piece of data for the user this. That's all they need. It's a little bit tricky for sessions because sessions are peer-to-peer, and for sessions we want to emphasize on ephemeral keys. So the encryption key for transport is always changing, and that's why you need to have the secure session on 2 sides. But sessions work really simply for developer perspective. You just push data in a session, and it's being encrypted, and keys are being rotated, and all without you even understanding what's going on there. And for authentication, we made a secure comparator that is zero-knowledge proofs-based authentication on social millionaire problem, which is not, how zero-knowledge proof works. Well, the idea is super simple without going into math. The idea is super simple. You have that's authentication, right? So you want to compare secret that you have in two different places. For zero-knowledge proofs, you compare the secret without actually sending it over the network. You send just derivatives from the secret over the network, and thus you can be sure with some percentage, you can be sure that the secret is the same. There are different zero-knowledge proof protocols, interactive and non-interactive. Some of them are used in blockchain. We use interactive protocol, which means that both parties need to do several hops to make sure that the secret is the same. I don't want to get inside the cryptographic details. Let's more talk about the library itself and the hidden problems. So, the first hidden problem is obvious. Crypto systems and that use different ciphers and that hide these ciphers from developers' perspective. This is how Themis looks like as a library. So instead of implementing our own cryptography, obviously, we used how called crypto backends. We use these large libraries like OpenSSL, Boring SSL, LibreSSL. These three we support as a stable versions. We also did a lot of experiments. Bear SSL, Wolf SSL. Have you heard about Wolf SSL? It exists, yeah. Bear SSL, Wolf SSL, like Lipsodium, Go Crypto, Ukrainian, of course, Ukrainian own ciphers, just because Ukraine has own ciphers. So the idea here is Themis as API works with different crypto backends, and we can, kind of switch them when we need. Basically, the core library is written on C, and it just provides, just uses these OpenSSL APIs in a fashion that from these core libraries, we have very, very high level, very, very usable, very, very understandable API on different languages. Right, so cryptographic backends, core written on C that works with these cryptographic backends. And then high-level languages like library per language. Let me probably enumerate them. For iOS and Android, for iOS, that's Swift and Objective-C. For Android, Java, Kotlin. For C, C++, obviously. Then Go, PHP as something old school. Then these hipster languages, Python, Ruby, JavaScript. And now we added WebAssembly. And of course, Rust. Yeah, sure. Many cryptographers like Rust. So now we have Rust. And now you understand why it's a nightmare. By the way, can you guess on how many languages of these I can actually write code? It's not perfect code, no, but it's somehow. How many? Tell me the number. How you estimate how good am I as a developer? All of them, close enough. Okay, most of them. I'm not into PHP, to be honest, really. For Rust for me right now is read-only, so I kind of read the code, but I don't really write on Rust. C++, C++ is a nightmare itself. I try to avoid C++ as much as I can. But JavaScript, of course, is better to avoid, but it's JavaScript is everywhere. So yeah, mostly I kind of write on most of them, not all of them, but maybe 6, 7 fluently. But we have a small team and we have this, interconnected skills. So we can support different languages with a small team. But languages is just one layer. Cryptographic library works somewhere, right? And for desktop and server operating systems, we support Ubuntu, Debian, CentOS, macOS, and now we start doing experimental builds for Windows. No one on our team has a Windows computer. It was tricky. It was really tricky. And currently we have this support. We even added to the docs, but we still mark it as experimental because the world of Windows is, very unknown for us. However, okay, operating system, right? But operating system, it's not like the name of the system. For all these things, we build and sign packages. And of course, these are just server-side, I called it server-side or desktop, right? Let's remember about mobile. I was too lazy to split Android because so many versions of Android. So yeah, when you want to build a multi-platform library, somehow you realize that there are too many operating systems in the world. And users, unfortunately, like their own operating system really, really a lot. And they're not ready to move to another operating system just because you don't want to support it. Okay, let's move next. Easy to use and hard to misuse. For cryptographic library, if it were you who are building cryptographic library, which you think is more important? Your API, your library is easy to use, or your API and your library is hard to misuse? Which is more important? Okay, let's vote. Easy to use. Hard to misuse? Ooh, wow. Well, from my perspective, it's both. Yeah, that's a tricky question. For example, starting from easy to use, can you guess? That's a real thing. Can you guess which cryptographic library is installed this way? This is like a copy-pasted from README. Which cryptographic library has this kind of installation process? All of them? Yes, most of them. But this one, you know it. You know it really well. It has SSL. All SSL. Yeah, close enough. Well, this is copy-pasted from OpenSSL. So really easy to do, right? Just download the library, run make test to make sure that everything's fine, make install. Of course, they have a way to configure the installation, so you can open the configuration file and configure all the things, because obviously you need to configure everything, right? And the point is that developers, they may not want to do all the things on all these machines, right? Especially they might want to install library if and only if this library is present in their favorite package manager. And now let's talk about package managers. Because again, operating systems are not enough. Each of them has their own package manager. For Windows, we don't really support like a real package manager. Right now, for Windows, you need to compile the installer, the installer, and then you can use nice installer with Windows GUI. However, these are operating system package managers. Remember about languages. Each of them also has like a preferred, default, industry-proven package manager. Some of them have several industry-proven package managers. Again, developers kinda expect you to support all of them, which might be fine if you work with one or two languages, but which might be a little bit complicated when you have 12 of them. And of course, every kid is a special kid. So every language is a special in a very, very different way. My favorite is iOS, because obviously iOS as an infrastructure, I was like, as an ecosystem, I was iOS developer for ages, and it's a pain. It's a pain. For iOS, like Themis for iOS has similar structure. It can use OpenSSL or boring SSL because Apple doesn't provide you neither of them as default options, so you need to install any of them. So it uses OpenSSL or boring SSL. Then it has this C language like C library, and then it has Objective-C wrapper. And thankfully, to the interoperability between Objective-C and Swift, we don't need to support Swift like separately. We just support Objective-C, and developers can use it either from Swift or from Objective-C applications, which is good. But the problem is with package managers. In iOS world, we have Cocoa Pods, we have Carthage, we have new Apple Way Swift package manager, and of course many developers still add libraries manually. Currently in Themis, we don't support Swift package manager because I just don't feel that I'm capable to understand what's going on there. It's so complicated to support if you have C, not only Swift. It's really complicated. So I just open an issue in GitHub saying, hey, if someone can help us to support Swift package manager, because it requires so much time. But in iOS world, things change really, really fast. For example, the iOS itself as operating system, we have this new iOS version every year, and we have minor versions several times a year. Usually minor versions are not a problem, but major versions can be a problem. Then, as developers, they use Xcode, which is IDE, and if Xcode provides Swift language version, and right now the current version is Swift 5.1. So it's a fifth version of Swift, and most of them don't have, direct, easy to use interoperability. So with each new Xcode that has each new Swift version, for each new iOS version, for each new iPhone, iPad, MacBook, and we need to make sure that everything is working, or to update things that are broken. Then package managers, of course, they have their own release cycles, and sometimes they also make updates. And OpenSSL and BoringSSL, sometimes they have updates too. So for iOS, it's just endless updating and updating and updating and updating, just to make sure that it's not broken on your latest iPhones. It's so fun. It's really so fun. Much fun. A lot of fun. Especially when you realize that you are not working on new features. You just want to make sure it's working as before. Android. Android is another kind of kid. So for Android, right now, for Android phones, Google has BoringSSL, yeah? You know the difference between OpenSSL and BoringSSL. So long story short, OpenSSL kinda old but bad because many bugs, they still support old school, deprecated ciphers. And at some point, Google decided to fork OpenSSL and call it BoringSSL. And we deprecated all ciphers, removed all the things, and Google actually patched a lot of ciphers, like a lot of problems in BoringSSL faster. But Google doesn't say you that you should use BoringSSL. They say BoringSSL, that's our library. Of course, it's open source, you can use it, but we don't promise you any backward compatibility. Moreover, they don't have releases. They just push everything in master. And good luck if new commit breaks the previous one. So, and on Android, we have BoringSSL by default. So for Themis Android, we decided, okay, we will use only BoringSSL. Again, BoringSSL, then the C core, then Java. For Java, we need the GNI layer, which provides API from C to Java. And then the Java. So, Android developers, again, luckily, to the interoperability between Java and Kotlin, they can use Themis, and we can support only Java, and it's fine. However, with GNI, with this layer, it's really complicated to debug what's going on. Either these are the problems in C level or these are Java problems. And with boring SSL, it's really complicated to support it because of all these problems with versioning. For example, recently, they decided they should stop supporting GCC. Why? Because I mean, I don't know. I don't have time to read the mailing list. I'm sure they have the proper validation of this idea. For me, it was suddenly because our builds on CI starts failing with nice error message. GCC is not longer supported. Thank you. Of course, we Googled and we did a really small fix. We just disabled GCC. So we say, okay, let's use Clang from now. But it was, it's not this kind of things you want to handle in the morning when you see red build from CI. Then we were saying, hey, why our Android builds are so slow? Okay, Android is slow. Okay, Android emulator is slow. Okay, but why building boring SSL is so slow? It can be 34 minutes. That's too much. And then we found out that we built all the things in repository, and boring SSL repository is a huge collection of library itself, tests, examples, tests, examples, and we build them all. And we're like, probably that's too much. We only need the library. So we add only we start building only library, and we decreased build time only to 12 minutes. 3 times. Of course, 12 minutes is also a little bit long, but better than 34. Then boring SSL, boring SSL. Of course, as Google, they have a lot of libraries for iOS. For example, if you're an iOS developer and you want to use Firebase, which is made by Google, Firebase uses boring SSL. That's why developers that already use Firebase and want to use Themis for encryption, they already have boring SSL, and it doesn't make a lot of sense to add OpenSSL at the same project, right? First of all, why? And second, because of the duplication of the symbols, it's really complicated to compile a project that has both boring SSL and OpenSSL because their headers are pretty much the same. So we did version for iOS, for Themis with boring SSL. Okay. And somehow we found out that Google does not support IIS XTS mode only for iOS in boring SSL. It's just not there. Boring SSL is very different, from iOS and not iOS. And this is something Google supports, so it's not like someone's fork. And I was thinking, what shall I do? Shall I ask Google to start supporting IIS XTS for boring SSL for iOS? Or I decided to do it in an easier way for me. I just found a place in our code when we use IIS XTS, and I found out that we don't actually use it, but we have it, as a symbol. So we have it as a header, and we did a great thing, which is disabled. We just used if define, and now we just don't mention IIS XTS in our source code for iOS that uses boring SSL. And just estimate how many of these feature flags we have in our code for each of these platforms. Okay, that was about easy to use. So to make library easy to use, you really need to spend some time. Let's move to the hard to misuse. There are different kind of abstractions level. Starting from Cypher through cryptographic library, cryptographic system, and a box solution. And when you work on a Cypher level, you have nice flexibility to use different ciphers, different modes, different paddings, yada, 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 yada. But it's actually a pain. and a source of mistakes. So for developers, it might be easy to use crypto libraries or even crypto systems, so they don't need to make, extra thoughts, and they don't need to have PhD in cryptography just to encrypt the data. However, when you start using crypto system, you don't have this flexibility anymore. You use just high-level API, and you can't actually customize it. So, for example, for Themis, we aim to be crypto system and maybe like even a box solution. So we aim to have really high level of abstraction. Why it matters? This is Common Crypto, iOS native cryptographic library. And this is how to encrypt data for using IIS in Common Crypto. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 11, right? 11 parameters. Just encrypt the data. Good luck. That's another library. And this is copy-pasted from README of this library. This library is super popular in iOS world. Super popular. However, it's easy. Okay, it's easier to do iOS encryption here. Only 2 lines. Not 11 parameters. However, most developers that copy-paste it from README already make at least two cryptographic mistakes. Because these are developers, come on, they don't know that IV should be random. They just copy-paste it from... That key should be like a proper key, right? I think key is a nice key. So the thing is that using this library, like developers need to understand that even if they copy-paste things from README, they do it wrong, right? And this is really popular in iOS world, like super popular library. 11,000 stars on GitHub. In Themis, for iOS, we have really simple API, like APIs that looks pretty much the same, however, without IV. And we kind of say that, okay, you don't need to put like super strong random symmetric key. We have KDF inside. Like, please make sure that your key is long and has enough entropy, but we kind of handle it. And you don't need to take care about IV. You don't need to take care about salt. You don't need to select the mode, all the things. And this is what I say, what I called hard to misuse. Because as we support all these 12 systems, we have similar API across 12 of them. Now, guess the language. Do you see it okay? Or we can turn off the lights if it's not really visible? Yeah, let's try to turn off the lights if you can. Just for, a couple of slides. Ooh, theater mode. Yay. Okay. So, guess the language. Python, no. Rust, no. Go, no. Swift, yes. Yes. Next one. Guess the language. Let me see. I think it's Rust. I think it's Rust. Okay. Next one. Python. Yeah, you see it's Python. So the thing, like the idea here is that we have pretty much the same API for each language. 2 lines of code for all these 12 languages. And we kind of handle all the choices of cipher suite, mode, padding. We handle like memory management, key management, and for more high-level functions like secure session, for more high-level crypto systems, we even handle authentication and work on keys. Thank you. Can we please turn on the light? Great. Yeah, you're doing great in guessing languages. Yay. However, as explained, there are so many things to work on. Probably, we should test everything. And just to show you the scale, So I counted a number of lines for source folder of Themis, and let's say that we have 35,000 lines, which is like a code lines, not comments, all the things, only code lines. And to show you the scale, for tests folder, we have 348,000 lines, 10 times more. Just because, to make sure that all these, you want to make a picture? Yeah, please. I know, the numbers are fascinating, right? I know. Just to make sure that all these 12 great languages on all these nice operating systems are working in the same way. We had a huge testing process. Of course, everything is automated because you can't see manually, like manual QA trying to test cryptography. It doesn't work here. So all the tests used are automated. Like for each language, a lot of unit tests. For cryptography, for CryptoCore, NIST tests. Then, of course, fuzzing. We use this American fuzzer loop, how it's called? LOP, yeah. We use it to fuzz inputs of mainly for high-level API as if we were not really good developers, right? And try to hack our own inputs of our own API. Then, of course, a lot of linkers, sanitizers, static code analytic tools, memory management tools, integration tests. My favorite bugs are bugs when application of Python encrypts the data, and application Ruby can't decrypt the data. So to eliminate these kind of bugs, because we have one of them between iOS and Android, sure. So to eliminate this kind of bugs, we built integration testing between all those languages on all these platforms. But this is not enough. Which bit is missing? I give you a hint. The library is being updated time to time. Which bit is missing? Versioning. Yeah, backwards compatibility tests. Because again, we need to make sure that the Ruby application that use previous version on Themis and encrypts the data can decrypt the data if they updated Themis. Again, it's not like we are so smart. We had these bugs. All these things, it's not because we're smart, because we had these bugs and we decided, okay, better we write test use for them than having them again. And these are a couple of links just in case you will also want to add some static code analysis things to your repositories and to your projects. I really like the second one, Clouseau. You know, like Inspector Clouseau. I don't know French, so I may be really pronouncing wrong. But the idea is that this tool reads through your code and tries to find out keys and passwords that you left in your code. It doesn't work for us because we write cryptography and we have the word key everywhere. So once we run it, we have like 300 false positives and we decided, okay, not for us, but it's really great. And to answer your next question, of course, you can't have one tool, to run all these tests. We use StochasAI and Bitrise as SaaS, as like public tools. And on our GitHub, we have for each like pull request, we have tests from StochasAI. They are really quick, but through the whole 12 languages. Bitrise we use mainly for Apple ecosystem, for iOS, macOS tests, and we put Android there as well. But all this integration testing, all this fuzzling, it's happened inside our infrastructure. We're using BuildBot just because when we calculated, amount of time these tests are running, we understood that we can't afford buying external services. We need to build on our own because these tests are really long. It's like nightly tests. And of course, last but not least, it won't work if you don't pay attention on the code. That's why we try to do this, security sprints, just to focus on specific potential issues we can have with when we store keys more longer than we should, or when we have like potential memory, like buffer overflow problems. And there is a nice link, cryptocoding, with a lot of ideas how to improve your code if you handle just in case cryptography. And of course, we do manual reviews, and this is where manual reviews are like good, because we have our own cryptographers on board, and we use external audits just because everyone makes mistakes, and just automated tests are not enough. Let's probably quickly skip this one, because again, it's not enough to have a library. You need to describe how to use it. And a lot of cryptographic libraries have one page readme. Sorry, it won't work. When we support all the things, we need to have separate readme for all these languages, of course. And of course, people say, I don't want to read readme. I want to copy paste. Okay. We put real code snippets in those documents, in those tutorials, free to copy, like safe to copy paste. However, people still ask questions. Okay, I can copy paste it, but where to put it? Fine, we made example applications. And again, showing the numbers, 1 million lines of code. For each this language, we made example applications. And imagine we need to build and test these example applications as well. Right? So amount of example apps is, I don't know how many times bigger than the source code. Then users are still complaining because their own app is not like example app. Of course, these examples are a little bit, artificial. They show how to use it, but they are not a real apps. They don't have like specific use case. And users start asking, but how can I use it if I'm building X, Y, Z? Okay. We build like tutorials. We build real applications, multi-platform applications. We open source a lot of things. We have this workshops. Everything is open source with nice blog posts explaining things. Still, users are complaining. It works in your app, but it doesn't work in my app. Okay, we said fine and build interactive simulators. So on our website, you can find a page where, for example, you can test your encryption. So as a user, you have, let's say, like Ruby application, and you encrypt the data there, and you want to make sure that you can decrypt it, that you configure everything fine. So you open our web page, you put encrypted data, base64 there, you put your key, and you make sure that it can be decrypted. Because if we can't decrypt it on our web, it means that you will be able to decrypt it like anywhere. It's fine. It's fine when it's like one blob of data. But as I mentioned previously, users want to build a real, secure session, a real communication between several devices. And imagine you have iOS application, Android application, and you want to build this secure communication. Right? You need to have both applications ready. You need to integrate TAMIs in both of them. And then you need to check if it's working. And you can have bugs on every step. So to eliminate this problem, we made interactive simulator, an endpoint that allows to connect and to check the session, the message connection. But users are still complaining. Users are still complaining. Users still asking questions like, hey, but if I do this, what should I do? We do our best. We really do our best trying to explain not only how TAMIS works, but also what are the possible attacks for this kind of crypto systems. How to make sure, like, what you need to do with threats, like how to make your application threats safe, what to do, how to handle memory. Then, of course, we try to, to collect all projects that use Themis and to say, yes, you're great projects because you handle security and you like protect your data. You're really good, and to mention all them just because people want to be mentioned. The next problem is that the encryption regulations. For example, if you use cryptography and you want to submit application to the App Store, you need to fill US export, like regulation report, what kind of crypto you use. And of course, as vendors, as providers of the cryptographic library, we kind of are responsible for people that use it and need to submit this report. But as not legal entity, we can't provide them legal advice. But again, we created a blog post and we described all the steps they need to do. And basically, this is a tricky question. If you're a vendor, are you responsible on how people use your tool, or you are not? I think it depends. 3 last slides, just to sum up. Themis is used in applications. In applications that needs to handle multi-platform. So it's fine to use like some single cryptographic library if you have single application on single language. But when you have distributed app, you probably want to have one library that works in the same way across all your infrastructure. And having these nice cryptographic APIs, this high-level cryptographic API, actually allows developers not to waste their time on making or preventing mistakes in cryptography, but rather to build the real, features in their apps. And one of these recent large cases, is a Bear application, note-taking app that decided to implement end-to-end encryption for user nodes. And we helped them to make it, and it's totally based on Themis. And on previous slides, you can see that amount of encryption, like amount of lines handled encryption, it's much less than amount of lines that handle all the key management, all these protocols. Just because having nice library, let's skip this, having nice library means you can spend your time, you can spend your time doing like a real job instead spending your time trying to eliminate cryptographic bugs. And like as a final thought of my talk, never ever agree to support cryptographic library. Trust me. This might be fun, but only like for a year. Not the whole journey is not that fun. And I really, really respect those people that do support cryptographic libraries. They are doing a great job. Okay, thank you. I ran out of my time, so for Q&A, please find me here. And you can find me tomorrow, because tomorrow I will have a workshop with Jean-Philippe in the middle of the day. Cryptographic workshop, more cryptography, less kittens.
All is said. Thank you very much, Anastasiia.
Thank you.